Right, the next thing we're going to do is move on to some of the proofs at the back of your trigonometry notes because it's Friday, so I want to keep on with doing that. So this is page 73 of your notes booklet, and we're going to prove the cosine rule. So the cosine rule, which we've been using, that tells us that when we have an angle like this, that the side opposite that angle is given by the two other sides squared and added together. Take away twice those sides by the cosine of the angle in between them. Okay, so how do we prove this? Well, the important thing is that we need to be able to construct this diagram. So you won't necessarily be given this diagram. You're going to need to construct it yourself. So before I even do the proof here, I'm going to go through what this diagram means. So you need to be able to construct this diagram yourselves. What does that look like? We're going to do it down here, okay? So you can label this and say that we are constructing the diagram. Here's the steps to construct it. We want to do a circle, and the circle's radius will not be 1. It's not a unit circle this time. So a circle of radius b. Okay, the important thing here is that the radius of my circle would be one of the known sides. So the b must be the radius of the circle. And let's do that. Draw a circle. And the center is going to be at 0, 0. Circle of radius b and center at 0, 0. So we'll do a cross through it. My x and my y axes are going through the center of the circle like that. The next thing we want to do is draw a triangle inside this circle. And we're going to draw the triangle so that the angle A is at the center at 0, 0. So draw a triangle with one side equal to the radius. Okay, so I'm going to just do it leaning back like this. It makes it just a little bit easier to see. That's going to be equal to the radius, like that. One side equal to the radius, and the angle, not an angel, the angle A at the center. So my angle A is going to be at the center, and the third thing we want to say is that the side C must be on the x-axis. Okay, so my side C, however long it is, might be shorter than the circle radius. We'll just assume that it's longer. So it comes all the way out to here, and that is my side C, like that. So when I complete my triangle, joining these two sides together, here's what my triangle looks like with the angle A at the center there. So that's the angle A at the center. Okay. Now, labeling this up. I hope you'll agree that whatever triangle we're given, you could draw a circle around that triangle so that the radius was B, one of the sides, and rotate the triangle so that the other side lands on the x-axis with the angle in the center. So that's the important thing here. Now, this is the point 0, 0, And the other points that we have, well, we have the point C out here. And because that's the distance C, this is the point C0. Okay, so that's one of the points on the circle. I've got 0, 0, I've got C equal to 0, 0, and I've got a point over here, which I'm going to call B. And we know that the coordinates of any point on a circle are given by sine of the angle, cos of the angle, when it's a unit circle. But when it's not a unit circle, when the radius is not equal to 1, you just multiply the coordinates. So it's B cos of the angle, B times sine of the angle. So those are the coordinates of the third point there. And those are my 3 points on my circle. Okay, and let's call this point A at the center. So those are my 3 points, A, B, C. And of course, the distance from B to C is little a. That's the distance that I'm going to be trying to find. Now, how do we do this? So the distance from B to C is little a, the side opposite the angle. Well, it's very straightforward. We actually just do it using the distance formula. So the cosine rule, once you have your diagram, what we need to do is draw your diagram, use the distance formula to find the distance from B to C, which is little a. Distance from B to C. So let me label this diagram as well. That's the point A, that's the point B, and that's the point C. Once you've done your construction, once you've drawn the diagram like this, it's okay to just go ahead and use our distance formula. So the distance formula, just a quick reminder, the distance between 2 points is the square root of the difference between the x values plus the difference between the y values, like that. And my 2 points are B, which is B cos of the angle A, B sine of the angle A, and C, which is the point C, side C, 0. So let's label our points and fill into the formula. Now, it's most convenient if we label them the other way round, just in terms of getting the signs to work out without us having to change the signs at the end. So I'm actually going to label this one x1, y1, and label this one x2, y2. The reason is I want the cosine to take away the other one. If you don't do that, it still works out, but you might make a mistake with the signs. So the distance from, we'll say B to C or C to B, is the square root of x2, B cos A, minus x1 minus C all squared, plus y2, B sine A, minus 0 all squared. Okay, that's just the distance formula. Now, B to C is little a. So we'll replace that, and I'm going to square both sides as well to get rid of the square root sign. So what I did here was I squared both sides to get rid of the square root sign. So a squared is equal to B cos A minus C all squared plus B sine A all squared. Okay, where did the 0 go? Well, when I take away 0, nothing happens. So what happens next? I've got to square out these brackets. So a squared is going to be, squaring out brackets like this, I square the first, b squared cos squared a. I square the last, c squared, and then I multiply them together and I double that. So 2bc cos a. Look at that. That's something that we expect to find in our answer. Over here I've got b squared sine squared a. Then we're going to do a little bit of algebra. We're going to gather these two terms together because they both have b squared in them. I'll leave c squared where it is. In fact, c squared minus 2bc cos a, that's actually in my answer. So I want that. I just need to deal with these guys here. So a squared is equal to b squared cos squared a plus b squared sine squared a plus c squared minus 2bc cos a. Here, I'm going to factorize out the b squared, and I get cos squared a plus sine squared a. Now I know it was a long time ago, but you might remember that the very first proof that we did was that cos squared a sine squared a is equal to 1. That's equal to 1. So I factorized out the b squared. And that means that I have that a squared is equal to b squared plus c squared minus 2bc cos a, which is exactly what we wanted. Just move this up. I kind of ran out of space there a little bit. You might decide that you want to do the proof in the box down below or on its own sheet, depending on how big your writing is. You shouldn't have skipped that line. Okay, so that was my proof. I'm done when I get to there. So going over the steps again. I need to be able to draw out this diagram. And here's the steps for drawing the diagram. You need to learn those and you need to be able to do that. Once you've done that, you use the distance formula between the 2 points that are here, because that gives you little a. And the distance formula has a square root in it, so we square both sides. That gives us a squared, and from there it's just algebra. So we're squaring out these brackets, and we end up with b squared cos squared a, b squared sine squared a. We put those together and factorize out b squared, which inside the brackets we'll have cos squared a sine squared a, and that's equal to 1. And that gives us our formula once we do all of that. Okay, so tonight I definitely want you to practice writing that out a few times so that you can learn it off, and do let me know if there's any step that you don't understand. Okay, thank you.